Well, hello, Brad. This is a game changer.
It is. This is some big news when it comes to cancer research and fighting cancer. But before we get to the big story, we need a little bit of a background explainer.
Class is in session.
Here we go. We're going to talk about T cells, and there is the technical name for them. Everybody calls them T cells. What they are is, and we all have them in our bodies, they develop from stem cells in our bone marrow, and they're also a type of white blood cells. So they're a really important part of our immune system. Essentially how they work is these T cells are on the alert in our bodies, in our bloodstreams. They're looking all the time. What are they looking for? Invaders. Maybe a bacteria, a virus, maybe cancer.
Okay.
And as soon as it spots it, it sends out chemical messages and all the T cells gather up and they go to attack it, okay? So that's how T cells work. Really an amazing thing, okay? So here's today's story, and I found this at SciTech Daily from the University of Pittsburgh, where this research was conducted. Scientists unlock the secret to supercharged cancer-fighting T cells. Okay, this is big.
It all sounds good.
Okay, so some of these cancer immunotherapies involve taking T cells from the cancer patient, they bring them into the lab, they grow them in large numbers in the lab, and then they put them back into the patient's body where they can go fight the cancer, okay? But there's a problem, Chris, because traditionally these T cells are grown in the lab in a sugar-rich media, which really makes them grow very fast.
Okay.
You can make a lot of them in a hurry, and that's what you want, obviously. But here's the problem. The cells become, quote, addicted to the sugar-rich media that they grow them in, and then they die very quickly when they return to the body because
They don't have it.
Correct.
Okay.
So that's the angle that they're approaching this from. So what they did is they supplemented the cell growth medium, that sugar compound, if you will, with another compound called dichloroacetate, DCA, okay? So it alters the metabolism of these T cells, making them less reliant on blood sugar and better able to use other energy sources more common in the bloodstream, okay? Here's the big advantage. These T cells live much longer compared to those grown in the traditional sugar media. So they were there to fight cancer a little bit longer. Look at this. In the mouse study, it's only been done in mice so far, but it looks very promising for humans. 1 year later, 5% of the circulating killer T cells were still those that they had transferred into the mouse.
After a year.
Correct. And those other ones that were not treated, usually they die within a few weeks. So now suddenly you have this huge window of opportunity to keep fighting,
Right.
okay? But there's a little bit more to it, okay? And this is
Okay.
where it gets even better. And this is a quote from the research. In animals with melanoma, treatment with the DCA-grown T cells led to a better tumor control and survival than with the traditionally grown cells. That's big in and of itself,
Sure.
okay? But here, provided long-lasting protections. They even gave those mice who had cleared the melanoma, they gave it the mice the cancer again, and the T cells fought it off again. Very big.
Effective.
Yes.
And efficient. All right, Brad, thanks so much for that
Okay.
news. We'll see you again tomorrow. Still to